Hello students. So this is the question number 3 based on the Thevenin's theorem. In this theorem the voltage is applied here and one resistance R3 is here, R2 is here and R1 is here, and this R4 is the load resistance. That means we have to find out the open circuit voltage here. So this circuit is different as in the previous two questions. Let's find out the Thevenin equivalent circuit of this. So first you have to remove this load resistance from this circuit and then redraw this circuit. So this circuit will be R1 and this load is removed from the circuit. This is A terminal and this is B terminal, and again this is R2 and this is, here you note that this is positive, this is negative, this is negative and this is positive, and the value, this is even and value is 8 volt, and there is another resistance which is connected here and the value of this resistance is 2 ohm and it is R3 and this is R1. Okay, now calculate the Thevenin voltage. Step number 1. Step number 1, calculation for Thevenin voltage. So you can see the voltage appear here when the load is removed from the circuit. The voltage appear here is known as the Thevenin voltage, and this voltage, suppose this voltage is VAB and that is open circuit voltage, is equal to the voltage drop across this terminal, because in parallel the voltage at these two terminals is equal to the voltage at these two terminals, because here there is a voltage and here there is some voltage drop across this resistance. That means this potential and this potential are not at the same potential. So that means the open circuit voltage is equal to the voltage drop across the R1. So that means we have to find out the current flowing through this resistance R1 and then find out the voltage drop across this R1. Okay, let's do the let us assume that this resistance R1 is here and this AB is here. Again redraw this circuit by considering the terminal A is here and B is here, and here you can see that this R1 and the R2, this R1 and R2 are in series, because here there is no current. R1 and R2 may be assumed as in the series. So here this is resistance R1 and this resistance is R2, and now there is a voltage source which is, this is negative, this is positive, and the value is 8 volt. Another resistance is R3 which is 2 ohm. Now calculate the voltage across this terminal. Suppose this is A and this is B. We have to find out the voltage drop across this A and B. So let's apply the KVL in this closed path, and because this is positive, that means the current flow into this way, and that's the current is I. Now write down the KVL equation for this loop, that is E1 is equal to IR1 plus IR2, and the value of the current will be I is equal to E1 upon R1 plus R2. Now we can find out the voltage drop across this resistance, that is VAB is equal to IR1, and IR1 is E1 R1 upon R1 plus R2, and this voltage is on the open circuit voltage, or here that is it is VTH, that is VTH is equal to VAB is equal to PAB is equal to E1 R1 upon R1 plus R2. Now substitute the value of this E1 R1 R2, that means VTH is equal to E1 is 8 volt and R1 is 6 ohm and R2 is 4 ohm. So that means it is 48 divided by 10, that is VTH is equal to 4.8 volt. This is Thevenin voltage. Now calculate the Thevenin resistance. Step number 2. Calculation for Thevenin resistance. For this, you have to remove the voltage source from the circuit. This has to be removed and load has been removed, and the resistance appear here is on the Thevenin resistance. So let's redraw the circuit. So here there is a resistance, that is R1. This is open, this terminal is A and B, and here there is a voltage source which has to be short circuited. This is short circuited, and here there is another resistance, this R1, or there one resistance is left, this is R2, sorry, one resistance is here, that is R2, and this is R3. Yes, now we have to find out the equivalent resistance of this circuit, and this circuit is grounded, and the resistance appear here is not the Thevenin resistance. We have to find out the Thevenin resistance here. So let's find out the equivalent resistance of these two resistance. Suppose there is a internal resistance of the voltage source appear here, then they are in the parallel, because here the resistance is suppose this is the internal resistance is equal to 0. Now equivalent resistance of these two will be, suppose this is R prime is equal to Ri into R3 divided by Ri plus R3, because it is 0 into R3 divided by 0 plus R3, that is 0. That means this resistance is to be short circuited. Now this circuit becomes R1, this is RTH, which has to be determined, and this is R2, and here there is no resistance, can be redrawn, and this can be written, and this is A terminal, this is B. Now this RTH A this is B, and this can be assumed as this is R1 and this is R2, because at this terminal, so this and this resistance is here and this resistance here. That means RTH is the parallel combination of these two resistance. That means RTH will be R1 dot R2 divided by R1 plus R2, and now substitute the value of this R1 and the R2, and R1 is 6 ohm and R2 is 4 ohm. It will be 6 into 4 divided by 6 plus 4. Now it is 24 divided by 10, and RTH is 2.4 ohm. And the Thevenin equivalent circuit is given by it will be this is R4, this is A, and this is B, this is RTH which is 2.4 ohm, and this is VTH which is, and here you have to mention the sign because here this is positive, that means it is positive and it is negative, so you have mentioned the sign. The VTH is equal to 4.8 volt, 4.8 volt, and this is positive and this is negative. Thank you.